Hello YouTube, welcome to the garage. The project I got today is troubleshooting a blower motor on a 2001 Jeep Wrangler. Okay, the owner of this vehicle is kind of a DIY guy, and he fired a parts cannon at it. You know, from what I understand, the new blower motor switch, the new ballast resistor, and new blower motor itself. I don't know if he changed the blower motor relay or not, but be that as it may, it still doesn't work. Nothing has changed. All right, and since he's a DIY guy, I kind of, was suggesting, well, why don't you pull a wiring diagram for it and, troubleshoot that. And he said he doesn't mess with wiring, and although I'm sure he's very capable of it, he's just apprehensive, obviously, because I'm guessing he doesn't understand how it works, so he thinks it's too complicated. So I'm going to try and demystify it, make it uncomplicated. This is a relatively simple circuit, so I want to go through my thought processes of how I troubleshoot a circuit like this. Alright, so I printed out from ALLDATA the wiring diagram for the blower motor circuit. Actually there's two circuits. One circuit for the blower motor relay, then the other circuit is how the blower motor gets power. So there's two circuits. Alright, and so you break it down. Anything that I do not have highlighted here, I'm not concerned about it. There is nothing in this area that is not highlighted that can keep this blower motor from not operating. The problem is somewhere in where I have it highlighted. Okay, so we've eliminated all of the stuff that's not highlighted, and also we've broke this into two parts. It's one circuit or the other. More than likely. Can there be a problem in both circuits? Absolutely. But it's likely one or the other. But we're going to test it all and see, exactly what the deal is. But what you want to do is make sure you understand the circuit and how it works. So it makes it much easier to troubleshoot it. So what I'm going to do is I'll explain both circuits. All right. The one circuit is for just for the blower motor relay. Let me kind of so I can zoom in a little bit here. I want to make sure you can see what I'm talking about. Okay. All right. What we're going to do is we're going to start here. We're going to trace this one circuit for the blower motor relay. All right. It starts, and this even tells you. I don't know. Can you see this? The fuse block is under the right side of the dash. Okay, right center of the dash. Okay, so the power goes from there. You follow along, and right here there's a junction there. Look at the camera. There's a junction there where power goes this way, but we're not worried about that. We're worried about the power that comes over here and goes to the relay. Okay, the blower motor relay. And this part of the circuit is only hot when the key is in the run position. You turn the key on, power goes through here into the blower motor relay, and then the ground side of it comes out and down here. When you turn the key on, what that does is it energizes this. It's an electromagnet, and it closes this switch right here. All right, just automatically closes that. Whenever the key is in the run position, this is energized, and this will be closed. At least that's the way it's supposed to work. When you turn the car off, this opens, and no power to the rest of the circuit. Close this switch. It closes for the other circuit for the blower motor. See, this circuit here is what actually closes this switch and supplies power to the blower motor switch. The rest of this, but we're just looking at this one, the first circuit here. So we want to make sure that when the key is on, we have a good fuse and we have power all the way to the blower motor relay, and when we have a good ground. So basically when we turn the key on, we need to have power all the way to the blower motor switch, the blower motor relay, and then you'll have a good ground. So when we turn the key on, this should close. Okay, you want to be able, you want to hear it click. You like to turn the key on, you can test, but we'll use a test light and we'll follow the power right along and make sure and just verify that we have power. And just because a relay clicks does not mean it's actually passing power through. You could have bad contacts here. But that's the first circuit that we're going to verify that everything is okay. From, you know, when you turn the key on, have a good fuse all the way through. Make sure that the blower motor relay is closing, and then also, you know, once we verify that, if the blower motor relay closes, and you know, then we know we have a good circuit here. So we would have ruled out this circuit. That's not what's causing it. This is closing, you know, that switch like it should, and so that means that that circuit is good. So we don't have to worry about that anymore. And then what you got is the actual power circuit. Let me get where you can see it. The power circuit, you know, and this is again the fuse is in the power distribution center, right side of the engine compartment. And this is hot at all times. This should always have power. This is so it's just right. It just has battery power, so this should be hot all the time. Again, this one's only when you turn the key on, you know, it energizes the circuit and closes, you know, closes the blower motor relay and lets this power go all the way to the blower motor circuit itself. But when it's when the key is off, this has power to it up to here, and then, you know, it doesn't go any further because this switch should be open. Okay, so verify you have a good fuse. Verify that you have power getting to the relay. So, you know, there's two places that power goes to this relay. One is switched and the other is not switched. Okay, this is constant, and this, you know, this then, you know, this is switched. You know, when you turn a switch on, energizes the electromagnet, closes that switch, then your power can go on its merry way. It goes to the blower motor itself, from the relay right to the blower motor. Okay, and the switch in the ballast resistor, you know, control the speed after the power gets to the blower motor. So when the key is on, you should always have power at the blower motor. All right, and then, you know, make sure the blower motor itself is good, but then you also have to trace it all the way down to the switch. Okay, now I always test these switches in the high position, you know, for when I'm testing for power of the circuit. I have the switch in the high position because with it in the high speed position, it's just a straight shot from the fuse through the relay, through the motor, all the way down to here, and then, you know, when you have it on high, it goes to ground. There's the ballast resistor is not in the circuit. I want to make sure that we have power from the motor all the way down to the switch. So you would test this with a switch in the high position, and the only other thing, you know, that you have to worry about is the actual on-off switch itself right here. And when you have this in either vent, heat, mix, or defrost, okay, as you can see, right here it shows you that the power is always connected. You know, this has nothing to do with the speed, but, you know, the power is always connected. This switch controls other things like blend doors and stuff like that, and we're not worried about any of that. We're just worried about the power. You know, the switch does do other things, but as long as it's on in either, it doesn't matter which mode, vent, heat, mix, or defrost, you're going to have path to ground as long as the switch is good. But over here, this switch, you want it on high because you're testing, you just want to test the main power to the motor. I hope I'm not making this too complicated. Let me back you up here a little bit. So just to kind of recap, you want to make sure I'm not confusing anybody. We have two circuits and we want to make sure they're both good. The one switch circuit provides power to the blower motor relay and closes that, and when you turn the switch on, that'll close that, and this constant power, battery power that's always there, once this switch closes, it'll feed power all the way through, to the speeds on high. It'll go straight through the speed switch, and then to the mode switch, and then to ground. And if you can, once you verify that the blower motor relay is closing, this, and it's passing power through the motor all the way down to the speed switch, and then through the on-off switch. Once that's what we're trying to verify, to make sure that that is all the way to ground, and if everything's good, the blower motor should work. And once you've ruled, either repaired or found out that the blower motor works on high, if it doesn't work on some of the lower speeds, then you're concerned about the ballast resistor, which gives it the 3 or 4 speeds, whatever it's got. That's the ballast resistor. But this just doesn't work at all, so we want to make sure that our power circuit is is good, and we're getting through power all the way through. Then the blower motor should run. Once we make sure that runs, and then this whole circuit is good, and then of course we'll test and make sure that the ballast resistor is okay for different speeds. But I want to make sure that I can have a good circuit with a blower motor that works. And testing in high, you can eliminate all of this. You don't have to worry about the ballast resistor. So try and make it as simple as you can. So we'll go out to the Jeep, and I'll kind of walk you through. Maybe it'll make a little more sense when you see me doing it, because I'm not that great at explaining it. So in a nutshell, we have 2 circuits we need to troubleshoot, and we're going to start at the fuse and work our way through the circuits using this diagram and find out where our problem is. So I'll see you out at the truck. Okay, here we are out at the Jeep, and the way I want to approach this is, how would I show a novice how to do something like this is kind of what I'm thinking. So with that being said, the way I would do is, first, we started off, we got our wiring diagram, okay, and we, South Carolina mosquitoes are ravenous tonight. But we looked at our wiring diagram, and we found out that we have 2 different circuits. One of them is hot all the time, and one of them is hot only with the ignition switch on. So what I would do, familiarize yourself with the vehicle itself, find all the components, alright? And so we're underneath the hood here, and as far as the power distribution center, which is hot all the time, that supplies the power to the one side of the blower motor relay. The power distribution center is right here. All your fuses and relays and what have you. And it's nice of them that they have things labeled. And what we're looking for is HVAC. Okay? And it's a 40 amp fuse. Over here is your regular fuses, your relays, some regular fuses, and then the larger fuses. And said this is a 40 amp, and I already have this ready to test to kind of make it a little easier for us. And while we're here, we might as well test. The first thing, familiarizing yourself with the system is a good idea, but I always test my fuses first. And while we're out here, I'll just go ahead and test this fuse and show you how I do it. Okay, so there's normally a little plastic cover on this, but I took it off. This is one we need to test, and I already took the cover off just to make it easier. All right, get yourself a test light. You can use a DVOM, a multimeter, whatever you want to call it. But we're just going to use a test light. They're cheap, easy to find. So hook the negative terminal up, and always check your equipment. Does the light work? Yes, our test light works. Okay, battery negative should be positive here, hot all the time. And it is. Okay, so we've eliminated that. We know that our fuse is good. And again, just because the fuse is good doesn't mean power is going through the circuit. So that's why when we get to our if you get to where you lose power, we have power here, and then when we go inside, because this goes to the constant power feed to the relay. Okay, if we get in there and we don't have any power, then we'll have to backtrack and find out where we lose it. But the power to here comes from that fuse right there. So if we get inside, and test it at the blower motor relay, and we don't have any power, then we have to figure out where we lose it between there and here. Okay, just kind of, that's how once you lose power, you kind of backtrack and find out what exact point you're losing power, and then address that issue. But we know that we have power at this fuse, and then the blower motor is on this thing is in behind the battery. If you can't see it, trust me, it's back there. Okay, so now we know where our components are out here. We're going to go inside, and some of this was already taken apart, and some of it I've taken apart just for so the video doesn't get quite so long. Okay, and then the next thing you want to do is we checked our fuse out there, and this like I said, we have two circuits. Okay, this one is hot all the time. We checked the fuse out there, it's good. Now we got this one, it's switched. Okay, so here's the fuse block, and down here is the HVAC, tells you which one is a 10 amp, and it's right there. Okay, that's the one we want to test. Alright, so I'm going to hook my test light to ground here. Make sure I got a good ground. This is switched. Don't forget to turn the switch on. Okay, now it should be energized according to that. Alright, so what we're going to do is test this fuse. Touch one side. I can see what I'm doing. Looks like, oh, there we go. That's hot. And that side's hot. Okay, so the fuse is good. Again, don't assume that power is going all the way through. All right, we have to, continue our quest. So what we're at now is good fuse here, good fuse here. Okay, and the next easiest place to test, in my opinion, is at the relay itself, the blower motor relay. And again, I tried to make this a little easier. I kind of got things down where you can see it. Alright, now we know that both of our fuses are good. The next place I would want to check would be this constant power to the relay, the blower motor relay, which is right here. I've already taken it down so we can see it. Okay, and we're looking for, what color is that? It's a red with a green stripe. Okay, that's this one right here. Okay, so this would be power coming from our fuse into the distribution block. So we want to test that, and we have power. Okay, all right, and I have the key off right now, but let me turn it back on, because what this does is, power comes in here, then it goes out of the green wire over to, let me get where I can see it so I can read it right. Yeah, the dark green wire right there is what runs the power through the blower motor and then over to the switch. Okay, alright, so what we're going to do is we're going to test to make sure that the relay is passing power through. I'll turn the switch back on. Okay, and like I said, we've got power coming in right there, And then if that relay closed, we'll have power over here. And we do. Okay, and you know, we can just test, you know, we know what we have to have power there. And then this wire, don't get yourself confused. Okay, that wire back there is the power coming in from the switch. Okay, we have power going in, you know, this is the feed, this is the load side, and this is the control side. The control comes from the switch, and then this is ground. Okay, don't confuse yourself. When you touch this, you're not going to have any, you know, the light's not going to light because it's just a ground. Okay, but since the relay closed and we have power going through the relay, we know the ground is good. It has to be working. So what we're going to do is we're going to continue and follow along our little path here and see where we're losing power. Okay, so we already, you know, we're at the blower motor relay. All right, so we have the control side. When you turn the switch on, it closed the relay, and it, you know, right here it closed this switch and provided power out. You know, we've verified that power is going out. Okay, and where's it going to? It is going to the blower motor. But you saw where the blower motor was. It's in behind the battery. It's a pain in the butt to get to. So where's the next easiest place to check? If you follow this along, would be at the switch, at the control switch. And if, you know, if we don't have power here, then you know you're losing it somewhere between here and here. But if we have power here, we know the motor's good because you have a continuity through the motor. So what we're going to do is we're going to look on the switch. Yeah, I already have it pulled out, and we're looking for the brown and tan. You see that brown and tan? Let me get my test light here. And brown and tan. This is kind of rough because I'm colorblind, so it makes it difficult for me sometimes to find things. Let me get over here and see if, let me get some light on the subject. You guys can probably see it better than I can. Let me pause you. Let me get up in the Jeep where I can reach something. Hang on. Okay, going to continue our quest, following the wire from the relay, but through the blower motor. And again, I want to this highlighted wire is the one that I'm interested in because that's just a direct feed to the ground. Okay, I'm not worried about the ballast resistor or anything like that. If we have, you know, I want to make sure the blower motor is good, and so that's why I'm testing. I'm following just this circuit here, and it's the brown and tan wire. And we, you know, so we had power at the relay, so we're going to make sure we have power at the brown and tan. Okay, I'm sure you guys can see the brown and tan better than I can, but it's right there. And we have power. Okay, so we have power to the switch, and I have the switch set in the high position. So, you know, so that we have power to the switch, and it should be going through the switch, and it comes out of the switch. Okay, what color is a dark green? Okay, so dark green. We have power going through the switch. All right, so just so we can verify everything we're doing, we have power coming out of the switch here all the way through. So that tells us our motor is good. All right, so we have power all the way through, and we're right here. Okay, so where does it go next? It's the same, I think it's the same, yeah, dark green that goes over to this selector switch, you know, it's kind of like the mode it's in. Okay, let me get a light to make sure you can see. So you have a green wire, then that's the power wire. Then the black wire is the ground wire. Okay, So what we're going to do is I'm going to test that green wire to see if we got power. Let me get probe down in there. There we go. We have power right to this selector switch. Okay, so it's either the switch is bad or the ground is bad. How do you know? Well, what I'm going to do is I'm going to hook the test light to battery positive, and I'm going to touch that ground. If the light comes on, I have a good ground, and that means this switch is bad. So I'm going to pause you, and I'm going to go hook the test light to battery positive, and we're going to test that ground. Okay, I've got my test light hooked to battery positive. So if I find a ground, the light lights up. Okay, so I'm providing power. All right, now back in on the back side of that green wire is the ground wire. Okay, I'm providing power to the ground wire. My test light is lit. That means I have a ground. Now, you know, there's something said about carrying a load, but I don't want to get too technical. All right, the ground appears to be good. I have power to that switch, and I have a good ground. So the only thing that possibly could be is that switch. So let me pause you for a second, and I'll be right back. Okay, I had to go take care of my test light so I didn't spark up anything. Okay, so we have power all the way to here, and we have a good ground. And you know, spoiler alert, I had actually already diagnosed this thing, and you know, I knew it was the switch. It's either the switch or this plug in here, because I was trying to unplug it. Hard to do with one hand. Can you see it? Are you in frame there? Trying to get this apart here. Well, when I tried to take it apart before, the blower motor kicked on. And I don't know why this won't come apart. It probably might be part of the reason why it doesn't work. It might just be a bad connection. There we go. Trying to get it apart. So the problem is right there. I don't know if it's a, well, there's a, see? The problem is right here. I don't know if it's a bad switch or if it's a bad plug, but I'll figure it out. But regardless, be that as it may, the problem's right here. Either a new switch or I need to, you know, put a new end on this. But that's what's wrong with it. Okay, and so pretty easy fix. But hopefully, I tried to make it as easy as I could. But kind of going through just process of elimination. You know, make sure your fuses are good, and keep following the power until you lose the power. And that's what we did. It was right at the end of the chain where we lost it. It was either the switch itself or the connection, you know, of the wire. So all I gotta do is figure out which one it is, and the blower will work again, and I'm sure the owner will be happy. So, I mean, hope that helps somebody. And so I'll quit rambling. Like and subscribe, and I'll see you in the next video. Little bonus footage here. The reason I couldn't get that apart, when you get out here in the sun, maybe you can see it. That switch was melted in there. Just melted the whole side of that, you know, beside that, you know, those contacts, melted a hole in that. And then check this out. Melted the whole back of this, so that whole switch got hot. I'm gonna have to try and find a new switch where it's not just, I don't believe it's just the plug-in here with resistance. I mean, I think that whole thing is bad. I wouldn't want to just clean these contacts up and try and reuse that. So just kind of a little follow-up of what actually was the problem, and just got to find a new switchboard. It's going to be fun for a 2001 Jeep, but I'll see what I can do.